Okay, let's dive right in. We're about to solve a mystery that's happening all around you, all the time. It really explains why things in our world act the way they do. And it all comes down to two different ways atoms connect with each other. So think about this for a second. You've probably done it a million times. You take a spoonful of salt, stir it into a glass of water, and poof, it just disappears, right? It totally dissolves. But what happens when you try the same thing with sugar? Well, it's a completely different story if you heat sugar up in a pan. It doesn't dissolve, it melts into this gooey, caramely liquid. Now, they're both little white crystals, so why do they behave so differently? Well, the answer to that puzzle is super tiny. It's at the atomic level, in the forces holding them together.
To really get it, we have to start with the atoms themselves and ask a really basic question. Why do they even bother connecting or bonding at all? What's in it for them? Well, it all comes down to one thing, a deep fundamental need to be stable.
And this brings us to a huge idea in chemistry called the octet rule. It's pretty simple, actually. It just means that most atoms feel happy, or, stable, when their outermost shell has a full set of 8 electrons. Think of it like a collecting goal. And this one desire is what drives them to interact with other atoms.
So how do they get that full set? Well, they've got a few options. An atom can get rid of an electron, it can snatch an electron from somewhere else, or it can find a partner and share electrons. The path an atom takes really depends on its personality, you could say. And these different strategies are what create the two main types of bonds we're looking at today.
All right, let's start with the most dramatic option, the giving and taking of electrons. This leads to what's called an ionic bond, and it's really less of a partnership and more of a transaction.
So the most important word here is transfer. In an ionic bond, one atom literally just hands over an electron to another atom. It's a giveaway, no takebacks. And that one simple action changes absolutely everything for both of them.
The classic example, the poster child for this, is table salt. That's sodium and chlorine. See, sodium has this one lonely electron in its outer shell that it's just dying to get rid of. And chlorine over here has 7. It is so close to having a perfect set of 8. You can probably see where this is headed.
So, sodium gives its electron to chlorine. Bam! Now, because sodium lost a negative electron, it becomes positively charged. And chlorine, which gained that electron, becomes negatively charged. And what do opposites do? They attract. Like crazy. Think of it like two super strong magnets snapping together. That powerful attraction, that is the ionic bond.
And what's so cool is that this tiny little atomic event explains the stuff we see in the real world. That super strong attraction is why ionic things like salt form these hard, rigid crystals. It also means they have really high melting points. And, getting back to our original question, it's exactly why they often dissolve so well in water.
Okay, so that's the giveaway strategy. But what if an atom can't just give or take an electron? What if the best way forward is cooperation? Well, that's where covalent bonds come in. And for this one, the key word is share. Instead of a transfer, two atoms decide to share a pair of electrons. They form a bond that holds them together. Nobody actually gives anything away for good. It's a real partnership.
A perfect, simple example is a hydrogen molecule. Each hydrogen atom just has one electron. Neither one is really strong enough to steal an electron from the other, so they compromise. They each put their electron in the middle and share them. And by doing that, both atoms get to feel like they have a full outer shell. It's a total win-win situation.
Now, this whole sharing setup creates materials with totally different properties. Covalent compounds, like water or the sugar from the beginning of our story, are often liquids or gases. They tend to be much softer and have way lower melting points. And they form these neat, separate little packages we call molecules.
So you see, we've got two completely different ways for atoms to get stable. And because of that, they create two completely different kinds of worlds. One is all about giving and taking, and the other is all about cooperating and sharing. If you boil it all down, this is the one difference you really need to remember. Ionic bonds transfer electrons, which creates charged particles. Covalent bonds share electrons, which creates neutral little molecules. Honestly, everything else just flows from that single distinction.
Let's just look at them side by side. Ionic bonds transfer electrons, usually between a metal and a nonmetal. This makes charged ions, which create hard crystals with high melting points. Covalent bonds share electrons, usually between two nonmetals. This makes neutral molecules, which result in softer materials with lower melting points. It all comes back to that one decision: transfer or share.
Okay, so this is all cool chemistry, but what's the big takeaway here? Why does this actually matter? Well, it matters because these bonds are, quite literally, what our entire world is made of. And I've got a couple of easy ways for you to remember which is which.
For ionic bonds, just think to yourself, ionic, I gave my electron away. It's a super simple trick that connects the name to what it does.
And for covalent, just look at that co at the beginning. It's just like in coworker or co-pilot. It means working together. Covalent bonds are all about atoms cooperating by sharing.
And just think about how this shows up everywhere. The salt on your food is ionic, the water you drink and the sugar you might stir into it, those are covalent. In fact, your own body, all your proteins, your DNA, is held together mostly by covalent bonds. This isn't just theory from a textbook. It's the actual blueprint for reality.
So in the end, it really all comes down to this fundamental choice on an invisible atomic scale to give an electron away or to share it is what determines if something is a hard crystal that disappears in water or a soft solid that melts in a pan. So the next time you season your food or drink a glass of water, you'll know about the incredible forces of connection that made it all possible.